Hello. So today we are going to solve a higher order linear differential equation using the reduction of order technique. Now, for our equation, it is y double prime plus y equals cosecant of x. Now, the first thing we could do is solve this equation as a homogeneous version. And we could say y double prime plus y equals 0. And then using a characteristic equation, we can conclude m squared plus 1 equals 0. Now, solving for m, we can get m equals plus or minus I. Now, from here, we can conclude that our fundamental set for our homogeneous version of this differential equation is as follows. It will be cosine of x, sine of x. Now from here, we can label cosine of x as y1 and our sine of x as y2. Now this is important for the reduction of order because we need a y1 or a y2, and we will use that to find our yp in this case, since it's a non-homogeneous version of a differential equation. And so by solving for yp, we could say yp equals either y1 or y2. Now, since this is cosecant of x, which is 1 over sine of x, let's say we use y2 and say v times y2. Now, to solve for our yp, we're going to use this idea of substituting yp as a first and second derivative into this original equation and finding our y of p by finding v. So we are going to do it as follows by differentiating yp. So for yp equals v times sine of x, we can say yp prime equals v prime sine of x plus, using the product rule, v times cosine of x. Now for yp double prime, we could say v double prime sine of x plus v prime cosine of x plus v prime cosine of x minus v sine of x. Now the minus v sine of x comes from the derivative of cosine of x, which is negative sine. So we just took a shortcut, and instead of writing plus negative, we just wrote negative. Now, after we have our yp prime, and our yp double prime, we are going to reinsert these back into our original equation of y double prime plus y equals cosecant of x. Now, in this case, we don't even need our yp prime, but we'll only need yp double prime and yp. So it'll look like this. v prime sine of x plus 2v prime cosine of x minus v sine of x plus v sine of x equals cosecant of x. Now with the reduction of order, we're looking to cancel out something. So luckily we have minus v sine of x and plus v sine of x, which means we can cancel these out, and we are left with v double prime sine of x plus 2v prime cosine of x equals cosecant x. Yet, after doing all of this work, we still have a differential equation of the second order. So, how do we solve this differential equation? Well, the reduction of order, the name of it kind of points to wanting to reduce the order of the differential equation from whatever it is, so in this case 2, so we should reduce it to 1. So what we are going to do is introduce a variable and call it w. And what w is going to equal is v prime. And w prime is going to equal v double prime. So what we can do with this now is say w prime sine of x plus 2w cosine of x is equal to cosecant x. Now from here we have a first order linear differential equation that is solvable using the integrating factor technique. So to do this, we want our w prime, the leading coefficient of w prime, to equal 1. So we are going to divide this entire equation by sine of x. So what we will get is w prime plus 2 cosine x all over sine of x times w equals cosecant x all over sine of x. Now from here we could simplify, because w prime plus 2 cotangent x, cosine over sine is cotangent, times w equals cosecant x all over sine x, which really is just 1 all over sine squared x, which is also equivalent to cosecant squared x. So we are going to leave it as in this form as of right now. So since we have the leading coefficient as w prime, we can denote 2 cotangent x as our p of x, and 1 over sine squared of x as our q of x. Now, from here, we will use an integrating factor and say e raised to an integration of 2 cotangent x dx, and this will be our integrating factor. Now, from here, e in the integral 2 cotangent x dx. To solve this integration, it is simply e raised to the 2 times natural log of sine of x in absolute values. And from here, we can rearrange it to be e raised to the natural log of sine squared x. And using the principles of e and natural log, this simply equals sine squared of x. And this equals p of x. Now I hope you all know how to use the integrating factor. So from here, it will be sine squared x times w prime equals an integration of p of x and q of x. And our p of x is sine squared of x, and our q of x is 1 all over sine squared of x, which leaves us with sine squared of x all over sine squared of x, which leaves us with 1, which is very nice for integration purposes. So from here, we get sine squared of x times w. Now, I mistakenly put w prime here, and it's not. If you're not sure how to do an integrating factor, look it up on YouTube. But this is actually sine squared of x times w, not w prime. Sorry for that mistake. And this equals x. Now, from here, to isolate w, we simply have w equals x times cosecant squared of x. Now, we haven't made much headway because we still have w, and we need to convert this into v. And w equals v prime, so we could say v prime equals x cosecant squared x. Now, in order to find v, it looks like we need to do integration by parts. So we'll try that out. And so v equals the integral of x cosecant squared x dx. And so our u will be x, our du will be dx, and our dv will be cosecant squared of x, and our v will be negative cotangent of x. Now, using integration by parts, it's u times v, and then v minus v times du. So what we'll have is v equals negative x times cotangent x minus the integral of negative cotangent x dx. Now from here we could say v equals negative x cotangent x plus the integral of cotangent x dx. And v can equal negative x cotangent x. And we could say it's plus the natural log of sine of x. You could say it's minus the natural log of cosecant x. It really doesn't matter if you just distribute the negative power into the cosecant, it becomes sine, and vice versa. So either way, it really doesn't matter. So from here, after finding v, remember we were trying to find yp after a lengthy process. We want our particular solution for our general solution. We could say yp equals v times, in our case we said y2. And if you don't remember, y2 was sine of x. So what we are going to do is we are going to say yp equals negative x cotangent x plus the natural log of sine of x times sine of x. And from here, we could say yp equals negative x cosine x all over sine of x times sine of x plus the natural log of sine of x times sine of x. And as you can see, the sine of x cancel for the first term, and we are left with yp equals negative x cosine x plus sine x natural log of sine x. And from here, we basically have our general solution. Remember, based on the principles of the composition, the supercomposition principles, you have for a general solution y equals yc, our complementary solution, which goes along with the homogeneous version, as remembered at the beginning when we set it equal to 0, plus our yp, which goes along with our g of x, which in this case was cosecant x. So we are left with y equals c1 cosine of x plus c2 sine of x minus x cosine of x plus sine of x times the natural log of the absolute value of sine x. And that is the general solution to the reduction of order formula, using the reduction of order to solve this second order linear differential equation.